This is better taste, less filling, JS in your JVM with Hegemon. I'm Kevin Clark, and I work for a company called Q. Q is a service that takes your email, contacts, and calendars, pulls them together into a snapshot of your day. It looks like this. So, for example, up at the top, we've got a calendar from GCal that's linked to a contact from my iPhone and an email from Gmail. The reason I'm showing you this is not because I'm pitching the product, but you should go take a look, but because everything that happens on this page, while being backed at the lowest level by a Java database, all these high-level things are chosen by JavaScript running alongside Java in the same virtual machine process. So to look at how we got here, let's look at where we were. So the old model was processes, right? You know, at the most basic level, when you're building something, you've got, that basic service, and you pick the language for whatever problem you're trying to solve. And as the service grows, you realize that you're actually solving more than one problem, generally. And so if you can divide that problem, then you can better pick your tools. So for example, we do this a lot with front-end and back-end, right? Your back-end may be in Java or C or C++, and your front-end might be in Ruby or Node or Python. The key idea here is that partitioning the problem lets us specialize our tools. The useful observation here is that this happens at different levels of scale. So if we take our front-end, back-end diagram and we zoom in on the back end, there's actually a lot of work that's going on in the back end to support its own front end, right? You've got some sort of REST interface. You've got some sort of serialization that's going out. And if you look at the problem that you chose your language for, you've got some set that's perf constrained, and the rest is just sort of chilling, right? You've got that inner loop that you really need to be fast, and then you've got all of everything else. So in our case, Q is built on Lucene, which is this great Java library for building low-level search engines. You would build on top of it. So we picked Java for that, and it's the right tool for search. But it's not the right tool for stuff like this. How many people have used Java to output JSON? Okay, so you end up with, to generate this, you end up with a class that looks like this, which is not that much stuff for Java, right? This is really pretty Java. But all of this to generate this, which sort of leaves a lot of us looking like this. What's happened is that the right tool for search has become leaky. And so these other concerns that we have to deal with to build this process gets affected by the choices we had to make for performance. So what our goal should be is Java where you need it and nowhere else. So that brings us to Hegemon. What is Hegemon? Well, Hegemon, for one, was inspired by the Ender series and is a set of tools for using the latest Rhino on the JVM. Rhino is an open-source JavaScript implementation written in Java. And Rhino is really great because it sort of straddles these two ecosystems, right? It's actually bundled with Java 6, and it provides this pretty much transparent bridge between Java objects and JavaScript while being a full JavaScript interpreter. The problem with the Rhino version in Java 6 is that it hasn't been updated in a couple years. Rhino's actually been in active development. It's a Mozilla project. And so there's been releases up to 3 or 4 months ago, but it's a little tricky to get into your system. So this is the work that Hegemon does for you. It makes it easy to embed. So let's look at some basics. So let's say we want to run just basic hello world JavaScript. This is the amount of Java you need to do it. You say, I'm going to have a new script. I've got some JavaScript source that I'm going to run. And down here we run it. Foo returns 7. The other piece on this slide, you're going to ask about the load path?
No, I was going to ask, why are you doing this instead of like Selenium or, for example, you just create bindings? I was just wondering.
So we've already got a Java process. We want to be able to reuse all of that code. I've spent, I spent 2 years working on the search core. I want to be able to call the search core without having to build any sort of external API to do it. So the other part on this slide is the default path. We've got a default path because Hegemon introduces its own concept of being able to load files. So if you want to load file in Hegemon, like here, we're returning this function that's defined in util. We add this third argument to the new script, util, and this will go to our default path and load that file. Similarly, you can do it from within JavaScript. So down here, we're doing the same thing. We've added load util into our JavaScript function, and now we can call defined in util. The reason we can do this is because the other half of the script constructor loads Hegemon core, which provides the load function. If you want to run stripped down JavaScript, no dependencies, leave this stuff out, and you can just run stuff directly. So the default load path loads from your resources directory, specifically in resources JavaScript. So if you've done some Java dev, you're probably used to projects that have more folders than files. If you'll notice down here, into the resources directory, this is where you're going to put your stuff to get included in the default load path. If you don't want to use the default load path, that's fine. We've got easy ways to override. Now, if you're going to be loading JavaScript files regularly, if this is a normal part of your application, then you're going to want to cache those loads, because every time you run it, you've got to pull it off disk, you've got to compile it, and then run your code. So Hegemon ships with a script cache. With the script cache, you give it your load path, you ask for the files, and you run them, just like you would before. If you need to invalidate the cache, you can always pass true. So this is the most bare-bones, stripped-down example. The way we at Q use this is over HTTP. So let's look at an example. Let's say I've got this function, get. Get takes some parameters, and all it does is return this JSON object. It says the method is get, and the params are this JSON object. And if we hit our service with a GET request, get script example foo equals bar, we want to be able to execute that code and pass through those parameters. And it should result in something that looks like this. So this little bit of Java, which admittedly is sort of a lot of Java, is all you need to do it. So let's take this piece by piece. This uses the Jersey framework to do HTTP endpoints, but it should work equally well with however you choose to ship your code. So at the top, we say we're going to use a path, and we're going to be able to grab the script name from the path. Additionally, it's going to be returning JSON. Then we initialize a script cache, just like we saw before. And we create a function that is going to handle our GET request, take the name of the script, and then curry the query parameters. Finally, we've got something that looks pretty much like before. We get our file, and we do it from the scripts directory inside our load path. We end up loading this common file because we're going to call getParams as objects, which is going to take the Java map and turn that into a JavaScript object. And then we call get, passing in the object. So let's see what that looks like. If we pull up my copy of IntelliJ, which is over here. So I've got this example service. I'm using Drop Wizard to bootstrap my process because all I really want to talk about is the endpoint. But I'm going to start this up. It's running almost exactly what you saw on the slide. It also handles post requests. And if I go to my terminal, and paste in curl, we hit it and we get params, foos, bar, and we return some post data. So all the code that was involved here is on my example service. I've added in my resource class. In here, this looks like a lot because it's got some comments and a little bit of error handling. But here's our script cache. Here's our get, which calls the run function. Here's getParams as objects and the run. And it runs this file. And that's it. So at this point, I can write arbitrary endpoints at consistent URLs that runs JavaScript. So there's other cool things we can do with this if we can just run arbitrary JavaScript. For example, we can do a debug endpoint. Right? The way this project was actually originated was we've got this server sitting out there, and we don't know what's going on. We want to attach a remote debugger, but a remote debugger makes the whole process slow and is really slow to bring back over the wire. So what we'd really like is some sort of console where we can twiddle the bits. Right? We want to say, what's this object doing? How can I run this code and find out what's going on? So the way we can do this is by doing an endpoint that looks like this. So we've got a path called eval. This one takes a post instead of a get. But then all it does is take our post body and shove it into this run function and then run the function. If you slap on a text area in front of this and a web page that posts to it, now you've got an interactive console to your Java project live. So again, if we look at our example service and the eval resource, that's all that's going on here. We compile a function and run it. And let's see where my mouse is. I'm just copying some code from a local buffer. So let's say I curl return 3 plus 4 and post it to this endpoint. You can't see it because it's on the side, but 7. You can also do more interesting things that show off some of the power of Rhino. Let's say we want to call a Java function. So here we're calling Java lang system current time in millis. So just like running JavaScript, I can run arbitrary Java over post. And because it's JavaScript, you can also do things like, Java lang system is sort of a lot to say, right? So why don't instead we give it an alias? So let's say system is equal to Java lang system. Then I just want to return system current time millis. Or, maybe this is too much. Maybe I want to do functional programming. Well, we can combine Java and JavaScript and say, actually, let's just call this function method, except I have to type it right. And now I call method and return that. So you get all the power of JavaScript with Java. This is really, really useful for debugging. We do it all the time. The one note for this is, if you're going to do this, please don't take my eval code and put it out on the open web. I'm going to feel really bad when something goes wrong. Firewall this. Put access controls on it. Don't put it out somewhere. This is just a debugging tool. So once you've got this out in production, you're going to want a way to test it, right? So how do we test it? Well, if we've got a function that looks like this, get params, returns method get and the params, really we want to be able to write a unit test that looks something like this, right? We want to take some set param, and we want to assert that we're getting get back as the method and the params back as the params. Well, if we're doing this as a Java project anyway, the most natural way is through something like JUnit. So with Hegemon, you can put in this much glue code, and now you're running your JavaScript tests along with your Java tests, and nobody knows any different. You can run it through Maven. You can run it through your IDE. It just works. So all that's happening here is we say that this class, which is really just a glue class, there's no functionality to it, is going to get run with the Hegemon runner, and it connects to our example test. The example test is going to be loaded from the default load path, and that's it. The one disadvantage of this way of doing things is that you do a lot of this. If you've got Java sitting there, then you've got to wait for compiling to happen to run your tests. And really, we'd like to be able to test faster, right? JavaScript developers are used to refreshing the browser and seeing things change. That short feedback loop is one of the things that makes it nice to work with. So we've shipped a way to do that. It's called the Hegemon test server. So the way this works is you cut and paste this big piece of code. In the next version of Hegemon, it's all going to be bundled in. And the important part here is that it gives the path relative to the resources directory where your code is. It needs to be able to load that instead of whatever resources have been compiled into your jar or staged or whatever. So at this point, you reload a browser and it works. So let me show you how that works. So here I've got this example JS test server, which was on the slide. I'm going to run it from my IDE. And it's running on port 7070, because that's what it says in the code. And all I'm doing is I'm hitting 7070 and then the path to the class that is the binding class. And I hit enter, and it runs my tests. In fact, at this point, you can also just run a single test out of the scope of the rest. And it's going to respond directly to changes. So let's say I go into my example test, and I just put in an assert true, false. So this should fail. And I reload, and now we've got a failure. And that's it. There's no recompile. It just works. So there's a lot left to do. This was extracted from our code about, I've done it over the last month or so. We released 001, which is the first public release, last week. The 001 doesn't really reflect stability. We've been using this for 8 or 9 months. It's just the first public release, and I'm really interested in this being a community effort. Sort of expect this to change. So there's still work to do. For example, we're going to release a Hegemon standard lib, which is going to bundle a bunch of JavaScript for you. For example, we've got lots of code that handles iteration over both JavaScript objects and Java objects and Java arrays, right? So that you can use the same function no matter what you're working with. You don't have to care. The load API is probably something that we may reconsider, right? Do we want modules? Do we want some sort of namespacing? We don't really know how this is going to change as it grows. And then there's some other crazy ideas that we could try out. So for example, internally, we do JavaScript updates without compiles or restarts. All you need to do is take your local JavaScript, push it off to the server, and tell it to clear its cache. And then you're running again. No JVM restarts, no recompile. You can make a change and push. You can be up to date in seconds. We've also got something internal that I'm looking to release called Hegemon.py. Hegemon.py takes advantage of our debug endpoint. It essentially takes all of your local JavaScript code, bundles it into a big file, ships it over the wire, and then runs it through the debug endpoint. The advantage of this is that if I feel confident that the code I'm testing out isn't going to delete user data or do something catastrophic, I can actually run local versions of the code on the server in an enclosed endpoint without affecting any users. In our case, we're a search engine, right? We've got huge amounts of data. My user index alone is 2 gigs. It's hard to bring that stuff down to test bugs. But what I can do is take my code, ship it to where the data is, and run it without affecting anybody else. And that's pretty cool. There's also some stuff we haven't tried yet. For example, I think this could be good for Cli Library Wrappers, right? Java's got 20 years of library development under its belt. What if we took our favorite libraries and made simple wrappers? You could do that in JavaScript. Right now we're using JavaScript to test JavaScript, but maybe we want to use JavaScript to test Java. I've heard of people doing this in the Ruby community or the Python community. There's no reason we couldn't be doing it with JavaScript. So the big goal here is to make it easy to be flexible on tooling. When you need performance, you're willing to make some choices to do that, right? Sometimes that means a lower level language. But really, you should be able to use the right tool for the right job when you want to do it, and it shouldn't affect the way you think about the problem otherwise. JavaScript is really nice for dealing with high-level problems where Java isn't in lots of cases. So if they can sit together, you've got no additional resources gained. You don't have a separate process. You don't need a separate box. You don't need to deal with how they're going to connect to each other. It all just works out. And then you get to take advantage of all the Java you've already written, and you get to port in JavaScript as you like. And that makes me a lot happier day to day. So this is Hegemon 001. I think the first version of, I think a 002 will be out this week. I was working on the standard library stuff, but had to write this talk. It's up on GitHub. We're really interested in this being a community effort. It's an Apache 2 license. And I'm really interested in feedback. Please do come find me afterwards. The other thing to say is that Q's working on some really interesting, hard problems. If you're interested in that sort of thing, come find me. We've got lots of problems to solve, and we're hiring. Questions?
Yeah, when your JavaScript dies deep in the bowels of Rhino, how can you bring a debugger to bear on it?
When the JavaScript dies in the bowels of Rhino, how do you bring a debugger to bear? In most cases that I've run into, the JavaScript, it either dies in our JavaScript or dies in Java. I haven't had issues.
It's the end user JavaScript.
Yeah. Okay. So
trying to debug it, you go to Firebug or you go to Chrome debugger or something.
You could. One way we do that sometimes is, like I said, through our debug endpoint. We'll ship the code over, and we'll add in logging statements. We've got some tooling so that it hooks into the Java logger, and it'll actually return that. So when you run hegemon.py, you get back a web response that's the JSON that's been output and all of the log lines. So it's printf debugging. It's not that good. I've spent 5 or 6 hours trying to get the Rhino debugger working with this, and I haven't gotten it to work yet. But I think with a little bit of community effort, it's something we can do. The other thing is that when the JavaScript dies in Java, you can always run this locally and run it through your normal debugging procedures. And the stack traces are tolerable these days. Better than some languages, worse than others. I saw another hand. Other questions? No? Okay, great. Well, I'm Kevin Clark. Please do find me afterwards. I hope you have a nice day.